afternoon. Glad to have you folks here. Glad to be able to be here to do something we haven't been able to do at the center for a little while. I think due to the efforts of all the folks and the whole shuttle team, as we got one in the air. So without further ado, I'm going to turn it over to the commander of this mission, Captain Dick Richards.
Thank you, PJ. Can you hear me in the back? Yes. Okay. Well, thanks for showing your support and interest by coming out here this afternoon. We put together about a 20-minute videotape, which are highlights of the things that we all did on STS-41. I'd like to introduce my crewmen. I was very fortunate and to have a great set of people on this particular flight. We've been asked to comment about what makes a successful flight, and if you put good people like we have in this room and at this center together with good hardware, it really gets easy, and it's a great thing that we do here. We launched on time. We've done that before in the past. I knew we could do it, and we did it, and we're going to continue doing those sort of things. But let me introduce my crew. Immediately to my left, one of our first-time flyers, and my pilot, very fortunate to have in this flight, Marine Lieutenant Colonel Robert Cabana. And they keep changing the order of sequence here to see if I mess this up here. But in the middle, another first-time flyer just reported here in 1987 and spent 3 years here and got an opportunity to fly in space. The first U.S. Coast Guardsman ever to fly in space, Commander Bruce Melnick. Next to him, our other experienced mission specialist, he was the bosun's mate on our flight. If for those of you who are not in the Navy that don't know what a bosun's mate is, the bosun's mate is the one that keeps good order in the ship. And Bill Shepard did that. A Navy captain, flew on STS-27, and I can't tell you how invaluable he was, not only to me, but to the other rookies, providing us with the right words at the right time on what to do and during those 4 days. Captain Bill Shepard. And lastly, all the way to the end, but certainly not least, Bill Shepard referred to him in our welcome home ceremony at Ellington as our secret weapon, and that's and I'll second that. Tom Akers, a real quiet individual, but I assigned him the responsibility of getting Ulysses out on time, and he did that. Those of you who worked with him know that a tremendous individual and really was a contributor and was absolutely essential to making the success of STS-41 happen for us. Not a bad job for your first flight, Major Tom Akers. And without any further ado here, if we can get the lights down and we'll roll this videotape, we'll try to narrate you through some of the highlights for STS-41. Well, here we are. We were pretty happy at this point because no flight crew had made it this far, at least being able to walk out to the Astrovan in about 6 months, so we felt pretty good. I had left word overnight that if we had anything to wake me up, and I had a nice sound sleep, so I was optimistic when we got up, particularly when we got out the launch pad and saw the weather. Bob will describe a little bit about what it's like to fly in the shuttle for the first time and have an ascent.
Well, as pretty as a day as we had for everyone watching, and as nice a view as it was, let me tell you, it was from a first-time flyer's point of view, it was even more spectacular inside. The Cape provided us with a super vehicle in Discovery, and she performed flawlessly. It was an extremely smooth ride uphill, especially once we got off the solid rocket motors. It was just a nice, steady acceleration out to Miko, and really surprised me how smooth the ride was. As you can see from our smoke trail going uphill here, there's very little wind shear. It was just an absolutely super day, and a super day to start an absolutely great mission.
During the launch count, it was absolutely almost identical to the one I had about a year ago. Everything was nominal. All the calls were as expected, and we had a real clean vehicle. The only thing we were concerned with the last few minutes was a couple of unplanned holes that we could tell would probably we'd be able to get past those, and the launch count proceeded. Then we had one cloud in the air that held us, and I think we were think we were about 5 to 10 minutes late from our planned takeoff time, but well before the end of our launch period.
At about an hour and a half after launch, Bruce opened the payload bay doors, as you see here, and he and I began the checkout of the upper stage booster system that was going to put Ulysses on its way to Jupiter and then ultimately the Sun. As you can see in that picture, we have an extremely clean payload bay, and that was true also in the crew compartment. The folks down at KSC did a great job on this vehicle. The checkout comprised the next 3 or 4 hours looking for about a 6-hour deploy of Ulysses, and in that time we checked out the upper stage booster system, the crew interfaces with that, prepared to activate the tilt table that would raise it to 60 degrees for deploy. Bob, our pilot, maneuvered the orbiter to several different attitudes to provide the ground with the corrections they needed to give the upper stage system a precise attitude correction. Here you see the deploy, and as the upper stage and Ulysses are pushed out of the payload bay at about 4 to 5 inches per second, you'll see in a moment in the background there things that look like particles or stars flying back behind the vehicle, and those were just ice particles that continued to come off of the orbiter for the first several hours that first day, and was really a spectacular show. At about a minute after deploy here, which again occurred at 6 hours and about a minute mission elapsed time, after 1 minute, Dick did a -X or a back-off maneuver where we backed away from the spacecraft, which gave us about 2.5 feet per second separation. As you can see, we deployed in darkness. And you'll see in a minute when the spacecraft comes into the sunlight, it was really, again, a very spectacular show. After 15 minutes from deploy, we did an ohm separation maneuver that ultimately placed us above and behind the spacecraft at about 40 miles separation. You'll see here in a moment the curved object you've probably heard about that appeared in the screen the first time we had noticed it. And they're still investigating as to what that possibly is. They think it's ice of some sort that came from the rear of the vehicle, and don't think it came from anything associated with the spacecraft or with the deploy. And there you see that object coming into view.
This was essentially my view looking out through the overhead window, and during the deploy sequence I didn't even see this object, and it wasn't until after we replayed the videotape that we finally picked it up.
And then again, as I mentioned, at about 65 minutes after deploy, we went into a window protect attitude so we could no longer see the spacecraft, and of course it was a long ways off by then also. And the first solid rocket burn of the upper stage occurred and was exactly as they expected it to be, and then the second stage, and then finally the third stage, the PAM-S solid rocket motor burned. And after about 16 or 17 minutes after that first burn, the folks on the ground started looking for Ulysses data and found the Ulysses exactly where they expected it to be. So it was almost as precise, in fact a little more precise than anybody on the ground had expected the 3 burns to be. And as of today, Ulysses is over 6.5 million miles away and doing much better than expected.
Tom and I cranked up the remote arm on the first part of day 2 and put it in this ram position you see here, in part to support the space station, but mainly to provide some data on the Intelsat solar array erosion that has been estimated.
This is a shot of the activation of the SSBUV, or the Shuttle Solar Backscatter Ultraviolet Experiment. It's a major secondary payload that we carried in the payload bay. Here it is, it flies in a gas can, a getaway special, and the SSBUV is going to be used to calibrate the NASA Nimbus satellites and the NOAA Tyros satellites, which are presently orbiting the Earth, measuring the ozone layer. It does this by comparing the radiation that's emitted from the sun with the radiation that's backscattered from the Earth. The ozone absorbs the radiation, and therefore they can measure how much of the radiation is being absorbed and can get a grasp on how much ozone there is in the atmosphere.
This is a shot of us getting ready to activate the SSCE, or the Solid Surface Combustion Experiment, which you've probably heard about, our fire in space. The data from this fire in this enclosed container was recorded on with two cameras, a 16 millimeter film. And as a backup, Shep came up with the neat idea of using our fiber scope to put down in front of one of the windows and record it on board our one of our onboard cameras and TV in the vehicle. And this is a recording of that we downlinked subsequently of one of the two views of the flame. Of course, the intent of the experiment was to evaluate the characteristics of flame spread in the absence of buoyant convection or in microgravity. We did this by igniting a small piece of paper in this container and then just letting it burn and photographing what happened with those cameras. The experiment's going to fly 7 more times with varying fuels, oxygen concentration, and pressure in the container. And of course, the application is going to hopefully improve our fire safety aspects of spaceflight. This is a shot of activating the IPMP, or the Investigations into Polymer Membrane Processing.
STS-41 was, although it was a short flight, only 4 days in length, was the first flight to start medical tests for future extended duration orbiter flights when we attempt to fly for in the 15 to 20 day time frame. And even though we had such a short flight, there was, of course, they want to anchor their database with the low end as well as the high end. This is I'm hanging on top of the escape pole there, and Tom is wiring me up with a blood pressure cuff device, which Tom and I wore for about 48 hours on the ship, and slept with it as well too, and hopefully give him some good data about how the heart adjusts to the sudden onset of zero gravity. This is a plug for my alma mater. They sent me at the last minute, a sweatshirt, which turned out to work pretty good to contain all of this extraneous hardware on this particular medical experiment.
Here, Shep and I are participating in DSO 472 and 474. It's retinal photography and also measuring his intraocular pressure. We did this 3 times on orbit to document fluid shift in the body and see if there was any correlation to SAS.
We all got a chance on board to work with 3 different types of laptops, and we also had the first orbital floppy disk here. And we're looking at various kinds of displays and also cursor control devices. Here's one called a Felix that will take the place of a trackball and may have some application down the road in space station.
That previous sequence there was the one, a lot of times we get accused of doing this in a hangar someplace in Texas, and so that last sequence with the disk was our proof that this was on board the orbiter in a micro-G environment. No flight crew movie can be complete without somebody being filmed playing with their food, and then in this case, it was me who got caught by Shep up there. Set of canned peaches that I had a lot of good time with. Tom mentioned that the Cape provided us with a very clean vehicle. I thought Columbia was clean on my previous flight, but this one was even better. We found very few extraneous objects, a total maybe of 3 that we put in our things found in Discovery bag, and we worked very hard to try to maintain the cleanliness of the orbiter, and you can see Tom tucking away his drink container, and also gave him an opportunity to plug this place in Missouri, and he can talk about that.
Yeah, this is an advertisement for my hometown, Eminence, Missouri, and of course the Red Wings are the high school athletic mascot.
Another important aspect of the flight was the time that we spent observing the Earth beneath us. As you know, we use a variety of cameras to document changes in the Earth's environment. We saw a number of them. Here we are coming up over the Tibesti Mountains in northern Chad in Africa. This is an active volcanic region on the Earth. We noticed a lot of fires throughout Africa and South America, and changes in the levels of lakes and also different volcanic areas.
Well, being in the Coast Guard, the only time they let me take pictures of the ocean was when we were over shallow water. And here we are over the Arabian Sea, just off Somalia, and if you look close in the middle, you'll see a ship's wake and the sun glint. We also observed several other oceanographic phenomena that are really only visible from Earth orbit, such as the souloids, the ocean waves, and also some spiral eddies. And we got to get a good look at some of those things while we were up there looking at the ocean in the sun glint. Also took some other Earth obs photos and other land masses. We crossed Central America and South America quite often up there, and a lot during our awake cycle. And also we covered Australia quite a few times. Here's a view going over Shark Bay and looking into the Shark Bay on Western Australia. And then we jumped to a scene in the central area of Australia, in the Lake Eyre area. The Lake Eyre area is very important to observe from space because of the different amounts of rainfall it gets really determines how much water there are in the different watershed areas. As we've already talked about, we have very many cameras that we use in the orbiter, and the next clip coming up is a demonstration of how we might be able to more automate how we use the cameras on the space shuttle, in specific the TV cameras.
For the last several days in space, and we thought you'd like to see how it's been working for us. George Salazar and his crew down there at the Johnson Space Center have put together a system that allows us to control the cameras without using our hands. We can just use voice commands to talk to the cameras. So here's a quick demonstration on how they work. Voice command, activate.
Select the monitor, then a camera.
TV1, Delta. Action.
Action.
Right. Stop. Tilt up. Left. Stop. Right. Stop. Change rate. Tilt down. Stop. Change rate. Tilt down. Stop. Right. Stop. Too much. Too much. Too much. Zoom in. As you can see, it's a great system, and we really like it.
At the end, on day 4, one of the things you have to do is get ready to come home, and Bob and I started off the process by doing the FCS checkout of flight control system. The orbiter AP, Bob cranked up one of our 3 auxiliary power units to provide hydraulic pressure out to our control surfaces, and just like any airplane you'd have out at Ellington or Hobby, one thing that the pilots do before they go flying is wipe out the flight control system and move the control surfaces around. And we do that just by letting the computers do that. Everything was extremely nominal and told us that we probably could expect a smooth entry.
The evening before we deorbited, Tom, Bruce, and I stowed the arm after having the Intelsat array out in the flow for a little over a day and a half. And all the arm ops were completely nominal.
We couldn't resist putting at least one orbiter sunset that we saw of the 60 or so that we did see. Here we are with one of our long-range tracking cameras coming in. We had a calm, beautiful day out there at Edwards, just like we expected, and for myself, the first time I've ever flown this vehicle for real. It matched very closely with our shuttle training airplanes that we have out here at Ellington Field, and the fact that I had done this about 1,000 times prior in our shuttle training airplane, it felt very at ease with the orbiter coming into Edwards Air Force Base, landing on the concrete runway out there, runway 22. This test, we did have a test of the carbon brake system on this particular flight. For those, some of you may know, we've got a new braking system here. And this was the second flight of it, and our objective was to put a moderate amount of energy into the brakes. And this is a series of 3 flight tests, of which after the third one, the carbon brake system will be cleared for nominal end emission usage. And appropriately having the sun go through with the Ulysses project there, the landing rollout, we thought that was an appropriate thing to conclude also. The braking system very, very smooth to me, and the orbiter responded just like it did in flight exactly to my expectations. It was a 15,000-foot runway, and we landed about 2,300 feet down the runway with about a 9,000-foot rollout. And as I turned to my crew just before we walked out of the white room, they had performed perfectly, in my opinion, for 4 days, and I said, this is the last time you guys can mess up and fall down the stairs. And as you can see, they did that just as equally well as they did everything else for the previous 4 days and the previous 9 months here that we've been together. A great flight.
Good afternoon. Welcome to the STS 35 Post-Flight Crew Press Conference. I'd like to introduce to you the Commander, Vance Brand, and turn the program over to him.
Thank you, Barbara. Well, it's a pleasure to be back here after a mission that we certainly enjoyed. I'd like to introduce my crew. Guy Gardner, pilot. We have Jeff Hoffman, MS-1. Mike Lounge, MS-2. Bob Parker, MS-3, Sam Durant's PS-1, Ron Parise at the end there, PS-2. We had a big crew. This flight, more than many, demonstrated the value of man in space as a flexible element, as the person who's able to do troubleshooting, to continue on with manual control after automatic systems have failed to perform like we thought they would. So I was just very pleased that we had those capabilities on board to use man as a flexible element. Finally, and most important, I think our mission really demonstrated teamwork. People on the ground here really got with it after we had some space lab failures, and they came up with ways for us to continue, and in the end, through manual pointing, I think our astronomers were approaching, if not equaling, the capabilities of the automatic systems that would have controlled the pointing of the telescopes. Much of the teamwork between the Marshall Space Center, the Johnson Space Center, and us in the crew in orbit came about in a short 12-hour period. Everything was pulled together here on the ground in that short of time to allow us to continue and bring in quite a lot of scientific information. So with that, we'd like to show you our film, and I'll start out with the narration, and then others will chime in. Our patch in Columbia, and Orion is the star field you see there, a very prominent constellation in the northern hemisphere. 7 crew members, Astro mission. This is what our ship looked like as it sat on the pad, and we were having breakfast actually late in the evening. Here we, after having received the weather information, we're in the suit room, getting suited, myself. We have Guy. We have Mike, Sam, Jeff, Ron, and somebody in there. There he is, Bob. Bob was helping a manager adjust his tie. 7 crewmen going out to the van. You know, we had a late night or early morning launch, whichever you'd like to call it. So it was a little before midnight as we were going out there.
Here come the main engine and ignition, which of course light up about 7 seconds before our liftoff so we can check them out. They stabilize, we pull the umbilical, light the SRBs, and we're off. Here you can see Vance waving to us as you go by the tower. And just a spectacular night launch. I've never seen one. They say they're spectacular to watch, but it certainly is spectacular to watch from inside as well. We managed to launch with almost a full moon, and here's a beautiful shot of us going right by the moon. There was a cloud deck at about 7,000 feet, which you'll see us light up here as we go through it. It was really spectacular to look out the windows and watch that approach. After 2 minutes, the SRBs have consumed their fuel, and we jettison them. Little rockets fire to push them away from the orbiter. And we continue to burn the main engines for a total of about 8.5 minutes, which gets us up to over 17,000 miles an hour, and we're up in orbit around the Earth.
Here we are, finally in orbit about an hour after launch, with a second burn having put us into a circular orbit. Going into orbit to do astronomy has 2 benefits. One, of course, is it gets you above the clouds, but that's not the primary one. The primary one is to get us above the atmosphere itself. You see a series of layers of atmosphere sitting above this rather pretty sunset. One of the first things we do on orbit is to begin opening the payload bay doors. This not only exposes the payload so the telescopes can see the stars we came to observe, but also the inner surface of the doors are radiators and allows us to start cooling the vehicle. Once that's accomplished, we began activating first the Space Lab itself with its computers that help us control things. In the payload bay here, you can see some of the elements of our payload. First of all, the X-ray telescope in the far back from the Goddard Space Center, and then here parts of the Space Lab, which was in fact produced in concert with us by the Europeans. Having activated the Space Lab, we proceeded on then to activate the IPS itself with its 3 large telescopes. In fact, once this platform with the telescopes is erected, that's about the last we saw of the X-ray telescope, which is hidden behind this much larger array of telescopes. With the telescopes erected, pointing out the bay towards space, we're now in a position to begin observing. First with the orbiter crew positioning the orbiter. You can actually see a little jet firing here on that frame right there. Once the orbiter crew gets the orbiter pointed in the proper direction, then the mission specialist could, in our case, begin pointing the IPS, the pointing system that had the telescopes, begin pointing it more precisely, sort of fine-tuning towards the exact star or galaxy we're working on. We had troubles with the automatic star trackers doing that, and we resorted to what we call the old-fashioned method of hand guiding. This was done with a lot of help from the ground, which Ron will talk about.
One of the really great things that happened this mission was to watch within one 12-hour shift of bringing up a whole new way of operating, where we had the Johnson Space Center Mission Control Center operating the instrument pointing system, commanding it, and the experimenters at the Payload Operations Control Center in Huntsville commanding the telescopes, and us on board doing the target acquisition and fine guiding. Towards the end of the mission, our efficiency was getting up to the point where we were observing just as many targets as if we had not had the failures. So we and the scientists also were quite pleased with that.
We were divided into 2 teams, a red team and a blue team. This is the blue team getting out of bed in the morning ready to go to work. We tried to maintain a lot of discipline and do everything by the numbers, so we're going to work by the numbers here, floating out of our sleep stations. It was a little crowded down there. These wide-angle views make it seem bigger than it was. It's always fun to experiment in weightlessness with things like bubbles of water here and observe the dynamics of that free-floating fluid.
Jeff was a little thirsty, I guess. Mealtime is very important, a chance to relax and recap the events of the day and play with your food a little bit. The school kids we show these to always like those scenes. Some more fluid dynamics experiments. Hygiene is very important. We occasionally took time to wash our faces. Where does that water go? Just living in the spaceship creates a lot of wastewater, of course. And normally that's held in a storage tank, and every day or so we dump that out into space, which is really a gorgeous sight if you get the sun angle just right. It looks like a snowstorm or a blizzard or a heavy rainstorm. Really spectacular out the window. As you see, we had a little clog in the line that dumped that water overboard, so toward the end of the mission we rigged up some tubing and were able to transfer that wastewater into storage bags on the inside of the orbiter.
Well, throughout all this problems with the orbiter plumbing, we kept right on trucking as far as the observations and kept getting good science data throughout. And I'd say really all of these problems were no more than a minor inconvenience. We had 4 people on board who have actually, at various times in our careers, have taught in universities. So we took this idea of teachers in space and the interest that NASA has in education, and we actually taught some lessons direct to classrooms on the ground with students. Here's Sam talking about